Welcome back. This is part 2 of 11.1. All right, so on this example, we are finding the arc lengths, or find arc lengths to find measures. All right, so find the indicated measure. On this problem, we're finding the circumference C of circle Z. So the circumference of circle Z. All right, so we're literally just looking for the entire circumference. So what we do know is we know that 40 degrees out of a possible 360 degrees, part over whole equals part over whole, equals the part circumference, or 4.19 out of the whole circumference, right? Part of the circumference out of the whole circumference equals the portion of the degrees out of the whole degrees. All right, so 4 out of 36, we could reduce this. This is 1/9. Cross products and solve. 1C, or C, equals 9 times 4.19. And 9 times 4.19 is 37.71. 37.71. And this is in inches. All right, so on our next problem, we are looking for the measure of arc RS. The measure of arc RS. All right, so when they're asking for the measure of arc RS, this is like the lesson yesterday. This is like in 10 something, right? When we did the measure of arcs. That's asking for your degrees. They're asking for the degrees. So arc RS, how many degrees? So they're saying basically what is the degrees here, right? Because the central angle and the degrees are going to be the same. So what do we know? We know that the radius is this, and we know that this is the portion of the circumference. So 44 out of the whole circumference, part of the circumference out of the whole circumference. What is our whole circumference? Equals how many degrees out of a possible 360? So what is the whole circumference? Part of the circumference out of the whole circumference. The whole circumference is 2 pi r. Part of the circumference out of the whole circumference is how many degrees out of a possible 360 degrees? Cross products and solve. 360 times 44 equals 2 pi r times x. So divide by 2 pi r. All right, so in your calculator, 360 times 44 equals, divided by 2, divided by pi, divided by 15.28 equals 164.99. 164.99. So this is approximately 165 degrees. Make sense? All right, let's try this one. This one's asking for the length, not the measure, but the length. So this one's not asking for degrees. This one's asking for the portion of the circumference. So they're asking for here. So what part of the circumference out of the whole circumference equals 75 degrees out of the whole 360? Cross products and solve. 9 pi times 75 equals, that looks like an 8, sorry, 75 equals 360x. Divide by 360, divide by 360. So our answer, once we put this in our calculator, 9 times pi times 75 equals, divide by 360 equals, and I got 5.89. 5.89, and this is in yards. 5.89 yards. Try this one. Pause the video and give this one a try. All right, so find the circumference of the circle. So we know that 270 degrees out of a possible 360 is 61.26, the portion of the circumference out of the total circumference. Cross products and solve. So we could reduce this if we wanted to. 9 goes in here 3 times. 9 goes in here 4 times. So 3 times C is 3C. 4 times 61.26. Divide by 3. And you get your circumference C. 4 times 61.26 equals, divide by 3 equals, and I got 81.68. Your circumference is 81.68. And this is in meters. All right. Once again, let's try this again. So we're looking for our radius of circle G. So what we do know is we know that 150 degrees out of a possible 360 degrees equals the portion of the circumference out of the total circumference. So they're first going to locate our circumference. Once we know what our circumference is, then we'll deal with figuring out what the radius is. All right, so we can cross multiply. So 360 times 10.5 equals, divided by 150. So 25.2 equals our circumference, which is 2 pi r. So divide by 2 pi, divided by 2, divided by pi equals 4.01. Our radius is 4.01, or approximately 4. Okay, depending on where they want you to round. The curves at the ends of the track shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path shown is 36.8 meters. About how far does the runner travel to go once around the track? Round to the nearest tenth of a meter. All right, so basically they're just telling you that these are semicircles. Okay. So, about how far does the runner to go once around the track? Okay. So this guy right here. How far is one revolution? Well, he's going 84.39 plus 84.39. Plus 1 circumference, right? Because a half and a half is a whole. 1 circumference with a radius of 36.8. So 2 pi r, a circumference of one circle, plus 84.39 times 2 of those, right? 36.8 times pi times 2 equals, plus parentheses 84.39 times 2 parentheses equals. I got 400.00. It's approximately 400 meters. In example 5, the radius of the arc for a runner on the blue path is 44.02. As shown in the diagram. About how far does this runner have to go once around the track? 44.02. Okay, so let's look at this. So 44.02. So if they're going the blue path, it'd be 84.39 times 2 of those plus 1 circumference with a radius of 44.02. 44.02 times 2 times pi. 44.02 times 2 times pi equals, plus parentheses 84.39 times 2 parentheses equals 445.37. 445.37. It says nearest tenth, so 0.4. 445.4 meters. And that is everything on our lesson on 11.1 circumference and arc length. I hope you enjoyed the lesson. Please like our video and subscribe to our channel for more free lessons just like this one. Have a great day.